Okay? Someone can multiply it through. Where did you lose the Carlos?
What is that equation called?
Huh?
What is that equation called? Is that the measurement equation?
So that's just
keep
H of
looking
t.
for that. It's on the homework.
So if we go to our answer, we need h of t minus 5. Okay, so we had h bar. My h bar was, this was the h bar. This is
No, what's H?
this here.
Huh?
What's H of T?
I have no idea.
H bar was minus 5.55 times 10 to the minus 5 s plus 0.11. Okay? Inverting that is this. Okay? And we found h of t. If you look at y prime, I don't need h of t, I need h of t minus 5. How do I get h of t minus 5? Wherever you see t, you replace at every single space t by t minus 5. So Brian, h of t minus 5 is this, putting wherever I have t, t minus 5. No t here, I only have t here. So it's simply going to be minus 5 times 10 to the minus 4 times 1 minus e to the
Yeah, I
minus
think that's the measurement equation.
0.111
we do
instead
measure
of t, t minus 5.
Isn't that the measurement equation? Oh.
It's this bar.
So now we completely found y prime of t. What was y naught?
That times e to the ds, negative ds.
No, no, no. Absolutely not. We already took care of the e to the minus ds when we wrote this answer. E to the minus ds is gone here.
Why?
H bar got rid of e to the minus ds with this. In the dictionary second entry. Alright. So we have u prime completed. Let's find the final result. We'll give the plot. Y of t is y naught plus y prime. Y naught, if you recall, we have 90% conversion, I believe, right? So it's 0.02. 0.2 was feet, 90% conversion means A is 0.0. Okay. So y of t, which is y naught plus y prime of t, which is 0.02 plus y prime of t, is going to be, you add y naught 0.2 to everything. This is what I have for y prime. You add 0.2 to everything. So 0.02 for t less than 5 and 0.0200 plus this results from minus 5 times 10 to the minus 4 is 0.0005. That's 5 times 10 to the minus 4 times 1 minus e to the minus 0.111 t minus 5 for t greater or equal to 5. That's it. So, for those of you who want to see a plot of it would be, here is time 0, until time 5, it stays at its original steady state value of 0.0200. And notice, if you put t equals 5, what happens to this term?
0.
It's e to the 0, right? 1 minus 1 is 0. you get the 0.200. The two meet. At t equals 5, I get the same answer for both. And then what happens? It declines, okay? It goes, what final value does it achieve? As t goes to infinity, this disappears. It becomes 0.2 minus 0.005. Now it's 0.0195. So it will end at 0.0195. And so it stays at that value until here, and it's an exponential decline, and it will decline exponentially. So if you have to plot that, that's the plot. It makes sense. If your field over concentration dropped, you expect the reactant concentration to also drop. So are we clear about this example? Any questions? Good. Let's now talk about the second part of the partial fractions expansion hybrid method. A very key to understanding this. This is an equation that holds for all values of S. So, let me see, I need to erase somewhere. I can't erase that. I finished the example. I can do it. Guess what tool we are going to be using for the second part here? We're going to be using solver.
Are we gonna use the computer on the test? Thank God.
Yeah.
Not, well, no, yes, you may. You may, yes. Yes, I take it back. Because certainly for the second part, we
No.
have to use computer.
Broke my heart.
Yes.
Like
Take it back again.
You'll be using computer tomorrow.
So,
But, okay, so second part of hybrid. And then, oh, one other thing, guys. Let's go back. Did I erase that? I just want to make it half done. Just erase something I should have used. Dummy. Dummy. Sorry, before I move to that. Why is that method not usable for the other coefficients? That's a question you can ask me. Let's go back to the example. What did I have? I had s squared plus 2. Cross that out, okay? I don't want to have to rewrite it, but consider cross out. That's the example I had. You have it in your notes there. I mean, you have it erased. The other classroom is nice, has 6 boards I can roll up and down. We saw how we can use it for C22. Why can't we use it for C21? Robert.
1 over 0 for C22.
Let's see why we cannot use it for C21. Robert said it, but let's understand it. What would be the method? I multiply both sides by s plus 2, which will make that C21 by itself equals. But if I multiply both sides by the denominator of C21, I only cancel the square part. I still have the first power here. And from here, the C22 term will still have the first power. Everything else will have s plus 2. When I multiply by s plus 2, so that's what happens when I multiply s plus 2. If I take s equals minus 2 now, what happens here? This becomes infinity. Equals. This will be 0. This will give me C21. But the C22 will become what? Infinity. Plus the rest of the 0. So I get the equation infinity equals C21 plus infinity. It's correct. But it has absolutely zero information on C21. Okay? So it only works with the coefficient of highest power. The method that Stephanopoulos book then proceeds to differentiate an equation. And because you have to differentiate ratios, it's not the easiest differentiation. You have to do differentiation, differentiation, differentiation. It's certainly not quick and easy after that. All right, so that's why I'm not using that method. I only use the quick and easy part of that. Clear, everyone? All right. So I just wanted to make that point before I go to the second one. So the key to this equation is that it holds for all values of s. Use any value of s you want, and it's a correct equation. Obviously, I don't want to use s equal root because I would get infinity equals infinity, no information. But any other value of s gives me what? If you put any value of s that is not a root here, you get a number, right? And you get a number for all the denominators here. And what do you have? You have a linear equation for all the c's. Plug any number of s, any value for s, and you have a linear equation for all c's. You can very easily set that up in the computer, very fast in Excel, and we'll be doing it in class exercise. Which is homework that we do together in class. I have some homework that are really nice for you because we do them together in class. Okay? Well, I know most of them. I use the values that I know, and then as many as I have left, just give this many different values of s, and you get as many linear equations as you need. That's all there is to it. And then you solve the system for as many equations as you need for as many unknowns. In this example that I erased again, I'm not going to write it again. In the example I just erased, I had 6 C's, 3 were quick and easy. The other 3 were not, right? C21, C31, and C32 were not quick and easy. 3 unknowns. Just give 3 different S values, and you have 3 linear equations for these 3 unknowns. Put them in solver, and you're done. Now, a few caveats. First of all, with this method, you need to have the roots very, very accurate. The solutions of the C's that you're not going to solve, very, very high. So we want to carry this at double precision and everything and so on. Second thing, you have to be careful about the placement of S's. Although theoretically, you can choose any values of S's that are not roots, if you put values of S's that are close to a root, you can have serious numerical problems. So you try to pick S's that are distance from roots and distance from each other. I like points that work well are midpoints between roots. Okay? So do we understand the second method? So, after finding all CI with an remaining is choose equal number of S values. Not close to goods for each other. To set up a system of linear equations polynomials and solve them, e.g. by using formula. Okay. So for that, I'll give you one example, an in-class exercise that we are going to be doing on next class. So on Wednesday, definitely have your computers. Okay? But let's do a second example quick and easy. So let's answer the second question that we would need to use the full hybrid method for. So let me get it from the notes. So question 2. So back to the example. I'll go a little bit faster this time since I hope to finish it in the remaining 17 minutes. So question 2. Not under ABC, now U equals U naught. How will measurement change if the feed concentration starts dropping at time 0 from 0.200